Hello friends, today we'll be talking about light emitting diode, LED for short. So light emitting diode, as we know, is having wide range use now in the electronics industry. So ranging from touch lights, from disco lights, display board, and so many other things, indicators and so much things. So light emitting diode has so many applications and is commonly used almost in every circuit, at least to detect when the circuit is working or not. If not for the lighting purpose, it can be used for indications. So today we'll be looking at what light emitting diode is and how it works and how you can actually use it so you don't burn it out. So many persons, when they design a circuit, within some days, few working hours, the light emitting diode goes off. So sometimes they won't even know why it keeps doing like that. So there are some couple of things you have to just know about light emitting diode to help you so that your circuit will not keep going bad anytime. So today first of all, we start by identifying the polarities of the diode. The polarities of the diode. Which of the leg is negative and which of the leg is positive, because that is where the first confusion starts. For some persons, for some hobbyists, electronics hobbyists, when they pick up a diode, so they won't know where to put the positive terminal and where to put the negative terminal. So they just try to guess around. If they put it this way, it doesn't work, they turn it around. They keep doing like that until it works for them. But today I'm going to show you how you can just, by merely looking at it, get to know which one is the positive and which one is negative. So that is it. If you look at this light emitting diode here, this LED, for example, number one, how you can identify the negative and positive is from the leg, from the terminals. If you look at this one, you find out that this one is shorter than this one. The length of the legs, they are not of the same length. So this is the way they appear naturally. Once you bring any light emitting diode, their two terminals cannot be of the same length. So the shorter one is the cathode, that is the negative side, while the longer one is the anode, the positive side. The longer one is the anode, while the shorter one is the cathode. So that is how, by looking at any diode you pick up, you can actually know the polarities. Where is the cathode and where is the anode? So when you want to test, you know exactly how to test. But in a case where by some, maybe any occurrence or by any means, the two legs have been shortened or have been tampered with. Okay, supposing you disordered it from your panel and you still want to know which one is negative and positive. So by that time, the two legs must have been tampered. Probably they might be of the same height, of the same length, I mean, or probably you can't just identify through the legs because they have been soldered before and desoldered. So you can just look at the plate. If you look inside the diode, you find that there are two plates inside of it. One is bigger and one is smaller. So one is big and one is small. So if we open this diode, inside of it, if you open inside the diode, you find that you see something like this. Okay, let me clean the board. Okay, if you open the diode, you see something like this and something like this. Then this is the housing. So these are two days outside. You find that inside every diode there is always a bigger plate inside and a smaller plate. If you look inside it, so if you look at it, the bigger one is the cathode, while the smaller one, the smaller plate, is the anode. So which means this one is the negative and this one is the positive. That is how you identify the negative and positive, by merely looking at the plate, the plate size of the diode. Probably if the legs have been tampered with. Okay, supposing it's a colored LED, probably you cannot see the inside, or maybe it's not transparent enough for you to look at the plate to actually detect the sizes of the plate to know which one is the positive or the negative. Or you want to ascertain the workability, whether the diode is still good or is bad. You want to ascertain whether it's still good or it's burnt out. Maybe you are troubleshooting a circuit and you don't know whether the maybe the diode used as indicator or touchlight is whether it's good or is bad. You want to check if it's burnt out or not. So all you need to do is you bring your multimeter. Here we have a multimeter here. So this is a multimeter. So all you need to do is to bring your multimeter. When you bring your multimeter, set the multimeter to this diode point. Okay, let me zoom it a bit so you see very well. Oh, okay, you can see it. Set the multimeter to this diode point. Look at here, you will see the symbol of diode. This is the symbol of diode. First of all, this is the symbol of diode. So this is cathode and this is the anode. So if you look at the multimeter, you see this kind of symbol here that I have indicated. You see the kind of, so turn this knob to this place. If you turn it to this place, then plug your probes. You put up probes. This is negative to here, then the positive to this place. So once you do it like this to test the diode, it should light up. If it doesn't light up, then you know that it didn't polarize it very well. Maybe you didn't check out the plate size and the length of the terminals. But with this, it should light up if it's good diode. If you get diode is still functional, it should light up. Suppose it doesn't light up, then you know that the diode is bad. Of course, there is going to be a readout on the screen of the multimeter here. There's going to be a readout, the resistance across it, so you can also look at it. But the diode itself will light up. Then supposing it doesn't light up and you put it the other way around, maybe let me say we change the legs. You put this one that is negative, if you put it here, and this one that is positive, you put it here. If it doesn't, if it will never light. It's not if it doesn't, it will never light. But if it still gives you a reading on the multimeter here, if it still gives you a reading with this kind of polarization, if it gives you a reading on the multimeter, you know that diode is bad. It's totally bad. So because a diode is a one-way conducting device, so it conducts current only in one direction. It's a one-directional conductor, so it conducts only in one direction. So if you put it this way, taking the cathode to the anode and the anode to the cathode, and it works and it gives you a reading, it then means that light emitting diode is bad, so you have to replace it. So that is a very simple way of detecting when your light emitting diode is bad. Or okay, like I said, that is the best way to detect whether the light emitting diode is still good or whether it has gone bad. So with that having been said, so let me give you a very simple sample circuit where you can actually use the LED, the light emitting diode. When I say the LED, I mean the light emitting diode. So a simple circuit like this. This is the battery, this is the resistor, then this is the LED itself. Okay, I missed something here. Okay, I missed something here. I should put a switch, because any circuit you build without a switch is not actually a good circuit, because if there should be a problem in the circuit, how will you now put it off? So it's always good you have a switch in your circuit, no matter how small the circuit is. So now in this simple circuit, this is the LED diode, this is the resistor, this is the switch, and this is the battery. So if you close this switch, the light emitting diode should light up if it's good, if it's well polarized. I've showed you how you can know the polarities of the light emitting diode. So if it's well polarized, it should actually light up with this configuration I've showed you here on the screen. So it should actually light up if it's well polarized, unless you didn't do it well. Okay, but the question will now be, how do you determine the value of the resistor you use here? Let me draw this thing. Let me draw it one. How do you determine the value of the resistor you use? Because it's not you just get any, you cannot just get any resistance that is, you might just use the one that has higher rating than the light emitting diode and it will not light up. You'll be thinking it's bad. So basically, how you get the light emitting diode to use is through simple calculation. Simple calculation from our, okay, from the basic Ohm's law, find out that V, which is voltage, is equal to what? IR. And in this case, light emitting diode, most of it is rated 20 milliamps. It's between 20 to 30 milliamps. Most of the light emitting diode. So since most of it is rated between 20 to 30, we are going to use 25 as the average amperage of the diode here. So all you need to do is, you already know the voltage you are using here. If it's, let me say, using 9 or 5 volts, let me just say 5 volts. Okay, let's say we are using 5 volts battery here, and then this 25 milliamp diode. So you substitute in this formula, what do you get? Making our resistance the subject of the formula, you find that you have this voltage over current, which means we will not be having 5 over what? 20 milliamps. 5 over 20 milliamps, which will give you the resistance value that you will use here. That will give you the resistance value you use here, so that this LED emitting diode will not burn out. If you connect it directly like that, maybe this source is having, the battery is having, or like 1 amp, maybe it's rated 5 volts 1 amp or something like that, and you use it directly with the light emitting diode, just like that, it will just go off, it will just burn off immediately. So you don't just try that. So before you use any light emitting diode, make sure you use this calculation and get the actual value of resistor needed for that circuit to work effectively. So that is very simple. Of it. So this is where I'll be stopping for this. This is just basic knowledge of the light emitting diode. Maybe in our subsequent lessons you can now use it in displays and all other things. I cannot tell you how you can use it for displays and in other indicators and so many other circuits. So thank you guys. Thank you for watching. See you in the next video.